The James Webb Space Telescope, or JWST, stands as humanity's most sophisticated window into the cosmos, a technological marvel that has revolutionized our understanding of the universe. Launched after decades of planning and development, this infrared observatory represents the pinnacle of human ingenuity and our collective desire to understand our place in the cosmos. Unlike its predecessor, the Hubble Space Telescope, JWST peers into the universe through infrared light, allowing it to penetrate cosmic dust clouds and observe objects that have remained hidden until now. From the earliest galaxies formed after the Big Bang to potentially habitable exoplanets orbiting distant stars, JWST is rewriting our cosmic story with unprecedented clarity and detail. Today, we're exploring one of JWST's most exciting discoveries yet, the detection of carbon-based molecules in the atmosphere of an exoplanet 120 light-years away, a world that might harbor vast oceans beneath its hydrogen-rich atmosphere. This discovery marks a significant milestone in our search for potentially habitable worlds beyond our solar system and brings us one step closer to answering the age-old question, are we alone in the universe? Let's journey to the constellation Leo, where a star named K2-18 hosts an intriguing exoplanet designated K2-18b. Located approximately 120 light-years from Earth, a distance so vast that the light we're now receiving began its journey over a century ago, this world has captured the attention of astronomers worldwide. K2-18b is classified as a sub-Neptune or super-Earth, with a mass approximately 8.6 times that of our home planet and a radius about 2.6 times Earth's. These dimensions place it in an interesting category, larger than Earth but smaller than the ice giants of our solar system, Neptune and Uranus. The planet orbits a red dwarf star, cooler and smaller than our Sun, completing one orbit every 33 Earth days. What makes K2-18b particularly fascinating is its position within its star's habitable zone, that cosmic sweet spot where temperatures could potentially allow liquid water to exist on a planetary surface. However, habitability depends on many factors beyond just orbital distance, including atmospheric composition and planetary structure. Using its advanced near-infrared spectrograph, NIRSpec, and mid-infrared instrument, MIRI, JWST has provided us with the most detailed analysis of K2-18b's atmosphere to date. The results have been nothing short of groundbreaking. The telescope detected significant amounts of methane, CH4, and carbon dioxide, CO2, in the planet's atmosphere, key carbon-based molecules that on Earth are intimately connected with biological processes. But perhaps most intriguing is the potential detection of dimethyl sulfide, DMS, a compound that on Earth is produced almost exclusively by marine phytoplankton. If confirmed, this would represent the first detection of a potential biosignature on an exoplanet. However, scientists remain cautious, as there could be non-biological processes producing these compounds that we simply haven't considered yet. K2-18b belongs to a recently proposed class of potentially habitable worlds known as Hycean planets, a term combining hydrogen and ocean. These are water-rich worlds larger than Earth with hydrogen-rich atmospheres and potential oceans beneath. The concept of Hycean worlds is expanding our understanding of planetary habitability beyond the traditional Earth-like paradigm. For decades, the search for habitable exoplanets focused primarily on finding Earth twins, rocky worlds similar in size to our planet, orbiting Sun-like stars at distances where surface water could exist in liquid form. However, JWST is challenging this narrow view by revealing the potential habitability of worlds quite different from our own. While traditional rocky planets in habitable zones remain prime candidates for life as we know it, Hycean worlds like K2-18b offer intriguing alternatives. If you have any question, drop in comments, kindly like, share and subscribe our channel for further more updates about space.